I'd like to welcome everyone to the weekly meeting of the Rotary Club of Jonesboro, 5-time reigning club of the year. So, inspirational moment. Be brave enough to live life creatively, the creative place where no one else has ever been. Alan Alda. We'll move on to the program. We'll have Assistant Governor Adam Sartner come up and introduce our speakers.
Well, first, let me say congratulations. Did you say that was 5 times reigning champions? Gary worked really hard this year, and I know he was extremely nervous following Brian Riga. Y'all came together in a very challenging year. And so congratulations on that. And poor Gary Clark. It just, somebody, I guess, hopefully it won't be in the next 2 years, because then it'll be my fault. So I'll be on Gary to make sure he holds the title. It's my privilege to introduce Alan Keith to you. A little history on him. Alan has spent most of his 45-year career in manufacturing. He has worked for a collection of Northeast Arkansas manufacturing companies in a variety of industries. Most positions have been focused in either engineering or management. In 2010, after completing the Master Engineering Management program, Alan started teaching as an adjunct for engineering technology at A State. Then in 2016, he took a position with ASU Newport, leaving manufacturing to teach full-time. At ASU Newport, Alan created and is teaching the CNC machining program. So what's he up to today? In the summer of 2021, so just recently, Alan joined A State Innovate as a strategic advisor. With his education in a variety of positions, companies, and industries he has been associated with. Alan has the skills needed to assist A State Innovate and help its members bring production from concept to reality. Alan has a deep desire to help people in their endeavor to create manufactured goods that could be viable products. He's got 2 guests he's going to introduce, but it was my privilege. He emailed me, said, hey, could I speak to the Rotary clubs? And how Alan and I know each other through a special way. If you've been to Christmas at the Park, you might have, or more likely, your kids or grandchildren have sat on his lap. He serves as one of our Santas. So I'd love to welcome Alan, Santa Alan Keith, to me up to the podium. Please give him a warm welcome.
Adam, thank you for those kind words. We're good? Okay. Coming to this group is very important to me. I have kept an eye on Rotary most of my career, but have never really been involved with it. Part of that is because I have spent a lot of years in manufacturing, and getting away for a lunch meeting is just not feasible a lot of times. So that's one of the reasons that I was very excited about the opportunity to come and speak to this group. A little bit about my background. I created a program at ASU Newport that teaches manual and CNC machining. Now, if you don't know what that is, it's milling machines, lathes, surface grinders, and it's a manual version of that and a computer controlled version of that. Part of that was to get this program off the ground. I had to do a little bit of homework. I was not at the level I needed to be able to teach this program when I first came into the position, but I did have the background that allowed me to get that resolved and get everything where we're able to do that. And we currently are teaching students. We graduate normally about 5 or 6 students per year, and that does not sound like very many. But the students that we do graduate are extremely highly qualified students. When they come out of our program, they go to work somewhere. I run across their boss at Walmart or somewhere else in town. They always have high praises of the students that come out of our program. So, and then what comes up next. I went to work in 2016 for ASU Newport, and about that time is when A State Innovate got started. Okay, there was a grant written combination of A State, ASU Newport, the Chamber of Commerce, and a bunch of other government agencies with a bunch of other letters that I failed to remember very often. The grant was written, it was started. Not long after that, we hired a gentleman, Ty Keller. Some of you may know Ty. He may have spoken to you in the past. And he was the director of the program up until about probably a year and a half or so. And he went on to other opportunities. And back about 3 months ago, I got a call from Andrea Allen. She's the director of the Delta Center, and asked me if I'd be interested in working for them on a part-time basis to fill some of the role that Ty had been doing. And so we worked all that out, which is not an easy task when you have multiple jobs for the government. They don't like that very much. But we finally jumped through all the hoops, and here I am. So I wanted to just give you a little bit of background on that. A-State Innovate its design is to take an individual or a group of individuals that has an idea, whatever that idea is, and to be able to help them take that idea and put it into production and to be a successful product at the end of it. A little later in this presentation, we're going to hear from a couple of people that have been an extremely highly successful organization in that individual manner. And A-State Innovate has been able to help them through that process. Now, they did a lot of work. Believe me, we can't take credit for what they did because they have done a tremendous amount of work, and we will get into that a little bit later. A-State Innovate consists of 3 different locations. We have a location called the Garage, and some of you may remember seeing that downtown. It was on Church Street, if I'm not mistaken. And we actually closed that location down and moved it on campus. And our new location is across over behind the police station, just right behind the police station back there. And we have a variety of things in there, and I'll go over that a little bit more. The second location is in the ABI building, and that's what we call the lab. And so that is probably the thing that I have dealt with the least. They're a little bit on the secretive side over there. They're not willing to give us a lot of information about some of the things they've got going on. But we do have that facility available. We'll go over what they've got available for people to use. And then the last location is one that I'm most familiar with. It's called the Shop. It's out on Kruger Drive, and it's in the old, it's in the WTC building out there, Workforce Training Consortium building. It's the old incubator building, if you remember that from years ago. And the reason I'm most familiar with it, that's where my classroom is for my CNC machining program is. In the Garage, we have a variety of pieces of equipment out there, 3D printers, laser cutters, table saw, miter, anything that goes with light woodworking. Those tools are typically what you would see in someone's small shop behind their house, but we have all those available, even a wood lathe. And we also have available some workspace for if someone needs to come in and needs office space to do some things. We have some of that available too. This is a picture of, yeah, you see that pretty good. We've got about 8 or 9 3D printers out there, and they vary a little bit. Some of them are your typical 3D printers. Others are resin printers. That's a newer style. It's a little bit different style 3D printer and does a little bit different type product. But we can do a variety of things being 3D printed out there. And some of the things that we do, it's just depending on what the person can imagine. But we see people come out and they make things. They actually go in and they'll sell those things on the internet. They'll go in and create a market for those things. The lasers, we have 2 lasers. Typically, we use those to cut wood, plastics, acrylic, things like that. They're not designed to cut metal. These are smaller scale lasers. We are looking at going in and building a larger scale laser to be able to do that, some metal stuff. But we do have facilities, other places that'll cut metal, and we'll go into that when we talk about the shop. In the Garage, we have a CNC router and some other woodworking equipment there too. The CNC router would would be something you would take in. You could engrave stuff on it, cut things out of sheet goods, sheet plywood. This is a project created by one of our ASU engineering students about a year or a little more ago. And most things, except for the framework of this, has been created in the garage over here. The little airplane was 3D printed. You can see it there. And this is you have a tablet that operates the software to run this thing, and you can actually move this thing around, and it really doesn't fly, but it simulates the flight in there. But this is the kind of thing that our engineering school is producing, is people with this capability to basically take nothing, buy a few components, make the rest of them, and they put something that's really interesting, and it's a real attention getter whenever we have students come through and look at the program, and it makes them, they get pretty excited on that. The shop. In the shop, we have the machining program over there, the CNC and manual machining. There's also the other stuff that goes along with that: drill presses, surface grinders. We've got sheet metal equipment over there. You can shear sheet metal. You can bend sheet metal. We do have welding and cutting equipment over there. We've got some basic electrical stuff. You could do soldering on creating some circuits on some boards. And then there is a wood shop over there that is more along the lines of a commercial wood shop. The table saw in it has a 5-horse motor on it. It'll cut. It's very large, very powerful, and you can cut just about anything you want to on it. There's also a 26-inch wide drum sander, and you don't see those very often, and we have one of those in our facility. We've got a 15-inch wide planer that'll take a board 15 inches wide and plane it to thickness. So we see that we've got a lot of that type of equipment over there, and we'll see some pictures of that in just a minute too. We also have office space available for someone that would need to rent some office space, whether they come in to start a business from out of town or whether somebody locally that just needs some place to operate out of. This is a picture of our CNC equipment. The Haas is one manufacturer that we have on site. We have 2 Haas lathes, and we have two Haas mills and 1 Haas lathe. And then Tormac is the other one. We have a Tormac lathe and a Tormac mill. The difference in the two, in a mill and a lathe, whether it's CNC or manually controlled, in general, in a lathe, the part will turn and the cutter stays stationary. On a mill, typically the cutter turns and the part stays. It doesn't stay stationary, but the cutter turns itself, and you move the part around it to put it in the position you want to remove the material from. Manual machines, we have a full set of manual milling machines with manual mills, manual lathes, surface grinders, bandsaw, drill presses, all types of things. This is a picture of the woodworking equipment in the shop. You'll see that's that 26-inch wide drum sander. There's a wood lathe. There's the planer, and there's that big table saw. It's very industrial type equipment, very high capacity. I don't have any good pictures of the stuff in the lab, and a lot of that's because of some of the stuff that goes on there. And some of this stuff doesn't mean a whole lot to me because I've not dealt with much of this yet. I will have to at some point. But I do know one thing that did jump out at me is that very bottom line down there. And it says a -80, a -20, and a 4-degree refrigerator. Now that did jump out at me. I don't think we'll probably see very many of those in town, except probably at the lab out there. But they have centrifuges, shakers to be able to separate out different things. Who is A-State Innovate? This is a list of the people that are either involved in it now or helped us get A-State Innovate started. It's all driven out of the Delta Center. And then you can see the variety of people that are involved there. Some people are in manufacturing. You'll see Nucor, Yamada Steel is on that list. Ritter Communications is on it. So there's a lot of stuff going on with a lot of different organizations. Some of the members that have been helped through A-State Innovate, FRAZ Labs is who the people we're going to talk to you here in just a minute. John Ames is he's a high school instructor, but he's got these ideas that just keep coming out of his head, and he's making those things a reality. He's coming in using our equipment and we help him, when we need to be able to go in and make the products he's trying to make, to try to make something that he can mass produce and sell as a money-making venture. Go Man Go is it's a movable, it's a powered scaffolding system. The gentleman that come up with this, we've been working with him, and we make most of the parts for him there in the lab. And it's just something that he's been working on for years, and looks like it's probably going to be something that may take off in the near future. Do Right By Me is it's more of a craft type thing. The lady that runs that, she does a lot of things where she creates these things that are things that my wife would typically buy instead of me. But anyway, there is a market for those, and she does very well with it. And then Claudia, and unfortunately I could not remember her last name. All I ever call her is Claudia. But and then Greg Slayton. Those people are doing other things in the facility there to be able to get things, get a potential business started. At this time, I'm going to introduce Paul Frazier. Paul is he's in Little Rock. They live in Little Rock right now, and they come up here to use our facility. We have the only facility of this kind in the state that allows this depth of metal manufacturing that's available. There's other places in the state that have got innovation systems and makerspace systems, but they don't have near the capacity that we have in Jonesboro. And part of that is due to ASU Newport, because we've got that CNC machining program, and that's part of A-State Innovate now. It opens up a whole new section to be able to do that. And so that's the reason that Paul and Felicia have come to Jonesboro to do this. I'm gonna let him talk a little bit more about that as he does that. One thing about Paul, if you notice the last name, some of you may have known a couple of gentlemen from this area with last name Frazier. His dad and his uncle were both teachers in Northeast Arkansas for several years. And so, Paul?
Hey, I'm Paul Frazier, and Felicia and I are with FRAZ Labs, and we make flashlights. Here's one of them right here. We would not have been able to do this, or at least not get as far as we are now, without A-State Innovate. It's yeah, there we go. That shows some of our old models that we did way back in the day, and then the stuff that we do now is a real leap because of our access to the equipment that we've got now. But I'll give you a little bit of a backstory and how we got to here. We I guess it was about 8 years ago, we decided we started want to make flashlights for some reason, and we really started the old school way. It was all right. Oh yeah, okay. It was we started just going to Home Depot. We bought some PVC pipe and LED and some wires, and it was really ugly. You know, you just get a proof of concept and you try and make something work, and it was so bad that you just rather than having a switch, we would touch the wires together to complete the circuit, and the light came on. So is that it on the slides? Oh, okay. But we went that way. We went through more Home Depot parts and stuff like that until we gradually became to the point where we had to get our own metalworking equipment at the house. And yeah, so yeah. we got a mill and a lathe, and that's what you use to make this kind of stuff. And we turned the lights, got it to the point where we had our own intellectual property, and we actually got a patent, and we decided we wanted to start mass producing. So we went to a machine shop, and we started getting them to do small batch runs of like 50 or 100. And we started running into issues. It was quality control issues and communication issues. And so we decided we had to do something new. And so we going blank on trying to say so. Yeah, we had major issues, so we started going to innovation hubs, and really there was nothing that had access to metalworking equipment, and so they were giving us traditional business advice like how can you cut costs, like cutting the cost on like getting O-rings cheaper, something like that, and we really didn't know how the manufacturing process worked with CNC equipment. And so we heard through actually through Ty Keller that ASU had access to the CNC stuff. And so we contacted them. We had to figure out how to use all the equipment, and we had to figure out how to scale, which was the main thing. And so we got in there and we tried to build competitive advantages, figuring out how to use fixturing, things like that. To make our parts. We wouldn't have been able to do it without having direct access to these machines. And so we've been able to establish a really big competitive advantage and get some scale by using these CNC mills and lathes. We've had to come up with our own packaging. We've got 4 different models now. We've gone through probably 200 prototypes to get it to the point it is now. And so we make all of the parts here except for like the LED, the battery, and the springs. And we have a mechanically based LED light that has a variation in brightness from really low levels to really high. And it's all done with our technology. And it's a piston based design that uses compression to alter the brightness of the LED. We brought some parts that I guess Felicia mentioned earlier that we made in the last couple of days, but you've passed them around. So yeah, anyway, that's pretty much what we do here. And yeah, if you've got questions or anything, just let me know. It's what does CNC mean? I believe it's computer numeric control, and it's the machine operates on it goes to different points. It's G code tells the machine what to do and where to go. And so you give it all these points in the 3-dimensional space. And so it goes to all these, and the tooltip will cut the metal either while it's rotating or the tooltip rotates. And so you have to, you really have to figure out how to take advantage of these machines to harness their capabilities. You know, people think that you can just put a picture in there, but you have to tell it all these different points. You can't take too big or too small of a cut. These are all things that you've got to learn up there in Alan's CNC class. So it's some equipment that not a lot of people know how to use because there's really not many people that go into manufacturing. So yeah. Well, anyway, y'all can come up and look at the flashlights if you want. I'll leave them up here. They, yeah, we do all of the stuff ourselves, sell them. We've got our website and all that stuff, but we've done it all through this program. So, FRAZlabs.com, FRAZlabs.com.
Thanks, Paul. Thanks for coming out and sharing this with what you've done with that. That was my failure, not to tell you what CNC stood for. Normally, that's the first thing I do in presentations when I do this, but the computer numeric code is what it's computer numeric controls. It's a programming language that is specific to these machining devices. And it's just like any other programming language. You have to know what to tell it to make it do what you want it to do. And we have a variety of ways to utilize this computer numeric controlled equipment. One of them is we can go in and manually write line by line code and tell it to do something. But the most efficient way, and what Paul and Felicia end up doing, is they take solid modeling software, okay, where they go in software, CAD software, and create a model of what they want to make. And then we've got software that'll convert it to the CNC code. And then that lets the machine know what's going on with it. It's a little bit technical, but after you do it 2 or 3 times, it's not as scary as it sounds. And so anyway, but Paul and Felicia both have become masters of that area. So they and it was by necessity. They had to learn how to do all that. And so, anybody got any questions? He said that the small one was about $80 and the larger one was $125.
Each iteration of the light. So when you make something and you get it, they take 2 or 3 weeks to CAD machine, they get it back to you, you get it and you say, oh, I don't like the way this interacts with this, or I don't like the shape of that battery tube. So you change it on your little drawing, you get it back to them. 3 weeks later, they get you a new one. So it takes a long time to prototype. Plus it's really expensive through a machine shop. So with this program, granted, it took us 6 months or a year to figure out how to turn the machines on, how to CAM, how to CAD, all of that. With this program, we can machine those parts like you all have seen and say, oh, it doesn't fit together right. The tolerance is too tight or too loose or this or that. And then you can immediately go to the computer, change it, machine a new one. It takes 15 minutes maybe. So the turnaround time's a lot better. We've learned a lot more. The design would not be what it is now without this program. And also we have 2 patents now because we're one of the only flashlights that doesn't have wires. So there's no soldered wires in any of our lights. It's all just mechanically driven and put together like Legos. So the 2 of us can put all of these together quickly. We can anodize them quickly. We don't really have to rely on anyone else to get us parts. Like with all the part shortages right now, it's kind of a pain. We don't really have any problems with that except our LEDs, which we're looking to do those next. So we can't say enough good things about this program.
One of the things I see these, they come up usually every other week or so and spend a week with us. And so I see them pretty much every day whenever I'm teaching during the semester. And I would go over and we'd talk and you go one day and they're making it like this. Well, the next day you come in, they've changed their design a little bit and now they're making it a different way. And it's obviously better, easier to make. And, but if you don't talk to them for a couple of weeks, then there's major changes that you see in these things. They stack up on you after a while. One of the other things too, if you look at this picture up in the upper right-hand corner, you'll see this is their packaging. And there's a gentleman that works with me over he works mostly in the garage, sometimes in the shop. His name is Mike Alexander. He's actually a full-time employee. He's one of my students. He came through my program, my machining program, and he got the opportunity to go to work for A-State Innovate. And the packaging has been a lot of his baby. He creates a lot of this different types of packaging and things for them, and typically makes them. But you can see that we can do it either out of a wood plywood or MDF product, and we can also do acrylic. And those things actually snap together to create that. And if you look at the one on the left where the flashlight's at, that just comes off the end. You put your flashlight in there, put the other one on there, and you're good to go. One thing too, if you look at the bottom right picture, they talked about some of the changes they made in their manufacturing process. The part on the right, the bottom right, one of those was with a prior process using one different kind of machining cutter. And they changed cutters and went to the one on the right. And you can see easily how much better, aesthetically, how much better that is. It's, you don't see the machining lines and all that, and made a much more valuable product. And that's just one of the many, many, many things that they've done to improve their process. Anybody else have any questions?
I was wondering if A-State Innovate also helps with the intellectual property side of it. Do you just help with the mechanicals, or do you help get patents also?
No, we have the ability to go in and help in all phases of all that. It was set up, and there's a group of lawyers that help with the patent side of it. There's marketing people that help if you need marketing help. Obviously, that's not my area of expertise, but we do have people, in the group that's associated with us that we can do that. And so there is for members, there is a membership fee. It's very reasonable. In most cases, it's almost minimal, but it's about $75 a month to be able to come in and use the facility. Along with that, you get support from me and from Michael Alexander to help you work through the processes. I've spent a lot of time in manufacturing and a lot of different types of manufacturing. And so what that means is I've seen a lot. And so it's very rare that I run across something that I've not at least seen something that was very similar to that process. And so I can help with some of that. So.
Can anyone utilize the program, or is it like an application process where you have to be accepted to come in and
No,
use the
anyone that's
facility?
available for anyone. They came out of Little Rock, and we've they've utilized it for 2.5 years here now. So it is open to anyone. We do have several ASU systems, the big picture ASU, several people from that organization that utilize it. But we've got other people too. Well, the one guy, John Ames, he's a school teacher, and he just he has got big ideas that he wants to be able to produce something finite and see if he can make it work. And so sometimes that success happens very easily. Sometimes it takes a while, and sometimes it doesn't happen at all. And so once again, I want to thank you for allowing me to come in and speak to you today. This has been a pleasure. I really enjoyed it, and from Paul and Felicia both, we all want to thank you for letting us come in and tell you a little bit about what we do.
We have one question on Zoom. If you could answer real quick, Stuart wants to know what CAD software you model with.
We have a variety of CAD softwares that we use. Paul and Felicia are using Fusion 360 on their project. We also have Autodesk Inventor available on campus, and we have SolidWorks solid modeling available on campus. The Autodesk Inventor and the SolidWorks is taught in my program. And so someone could easily come in and take a class and be very proficient at SolidWorks or Autodesk Inventor within one semester time in there. All right. Thank you once again.
Thanks, Alan. Alan, for coming, and Felicia and Paul, appreciate y'all sharing your story. All interesting information. Next meeting be next week, passing of the gavel. I'll move from up here to somewhere back there. So anyway, we'll have some other presentations, and then we'll pass the gavel and swear in all the new board members and officers. Thought for the day: change is inevitable, but progress is truly optional. Don Allen Holbrook. And don't have anything else for the day. Appreciate y'all coming. Have a great rest of the week, and we will adjourn.